Welcome to the Rhize podcast, episode 7. This is the third and final episode with Geoff and Andy, so I'm doing the intro again. It's a continuation of the previous conversations. Thanks for listening and watching.
Another concept that we talk a little bit about, this is some pretty heavy stuff, is, when we first did our first two episodes with regarding the ISA 95 standard, and when you go back to, when it was created and even in some recent books that have been published on it, the intent of the standard was how do we exchange information between our level 4 and our level 3 systems? What does that look like? How do we integrate our business systems with our manufacturing and or operations systems? And that's, the intent of the standard was, how do we want to model the data? What do we want it to look like? What are all the things that go into it? But as we've evolved the manufacturing data hub, we almost look at it as an ontology for describing the manufacturing process. Can you go into a little more detail of, what do we mean by that? It's not just how we move data around. We're going to use this as the standard, for the ontology of just describing what does our company do.
Yeah, and it's such an important piece. For those that are observant in backgrounds, be able to tell that my background and Andy's background are remarkably similar. It's because we're sitting in different rooms at the same hotel at the moment. We were chatting yesterday actually about how the ISA 95 language is this incredibly rich, very, very specific language that gives you words to describe very, very precisely exactly what you're talking about in this very complex manufacturing domain that we all work in, and a very detailed structure of laying stuff out. But the language lets us communicate in a way that those who are familiar with the ISA 95 language can understand. And Andy, you and I were chatting about this with some engagements with customers where we've gotten further into and deeper into a problem because we've had this common language. I wonder if you had an example that maybe we could talk about here.
Yeah, it's particularly in IT or technically led engagements where you're looking to solve a specific set of problems or a specific set of use cases. You can often find yourself constrained by the domain that you can see before you, particularly if you've not got too much experience in general manufacturing, as it were. So you can end up in a situation where you can only deal with what you can see, with what the customer communicates with you, and you can only deal with that which has already been laid out. So in a specific instance is where you've got data streams of incomplete data coming up from the shop floor, and they look a little bit like MES data, but there's not much structure to it. And this data can end up landing in a data science or machine learning environment. And that's where the problem solving begins, with really great technical people looking at the problem and taking the approach of domain-driven design, really, I suppose. The domain-driven design approach says that, we talk to our customers and our stakeholders and we understand their language as they understand it, and we bake that into our solution, and the objects that we create and the things that we're dealing with have the same names, and through that, what we can end up doing is that having this greater, closer affinity with the customers and the stakeholders and that kind of thing. But there's a kind of flaw in that plan, that the language might not be right, the language might not be sophisticated enough. So what we end up with is a domain that's quite limited, a domain language that is quite limited, and data scientists or engineers that are trying to solve very difficult computer science problems are kind of restricted into talking about columns and rows and streams and tables and databases and that kind of thing. And what they're not talking about materials. They're not talking about, is this a work order, or is this an operations segment, or is it a process segment? And what ISO 95 allows you to do is kind of, it gives you a domain language, and it gives you a place to put your data and concepts that you can bring in and kind of take your discussion a bit further. So on the first glance at a particular situation, let's say you've got a material table somewhere. There's a material object, and that material object has got a column in a very a first stage prototype MES, and that material table has got a run speed. This is the speed that this material runs at on a specific machine. And then you take you try and take this further, you try and take this situation further and try and apply this new MES system that you've got onto a second line. But for this same material, the run speed is different on the second line. So what you can end up doing is adding another column to your database saying, run speed for line 2. And your journey through the problem space is defined by each time you run into the next problem and the next problem and the next problem after that. And that really simple example I gave, it would be obvious to a lot of people. But it happens. That evolution happens, and sometimes we find customers starting from scratch with their domain, where their back end is SQL Server or Postgres or something like that, and they can't actually get the conversation through all the way to where it needs to be. And with the way we approach consulting, we've got a kind of a root and branch approach to really analysing the process and really trying to understand what is this data. And it may be that the run speed does belong as a material property. It may be that the run speed belongs not on the material property, but on a process segment. Or it could mean that it belongs on an operations segment, or even on a work request. So maybe somebody in planning decides what the run speed needs to be at the time of planning because of some variable that's only available at that point in the process maturity. So with ISO 95, what we give ourselves the opportunity to do is make a selection of, we're not confined to just this little materials table, because that's the extent of our domain knowledge so far on that project. We've kind of got a big menu, a big selection of places where we can choose to land the data. And in a specific project that we've been doing recently, there's been a really good team trying to solve a lot of problems for a couple of years really, and they've been constrained by this, and we've been able to sort of come in and say, well, what we're looking at here, it looks like machine data, but actually it's not machine data. These are job responses, and actually we need to create a job response for every time this group of machine data changes, and we probably need to add some properties to the job responses. And then when we get that far into the discussion and everybody understands it, we've got sort of many heads able to talk the same language and discuss whether, okay, so if this is job responses, then we can relate our job responses back to maybe a process segment or maybe an operations segment. Where do we put that bit of data? So we can very quickly, but rather than getting kind of bound up in conversations about columns and rows and a kind of a partial domain language, we can advance the discussion into something that's a bit more sophisticated, and take the problem much further. And that does happen quite a lot, where we're using the ISO 95 as a backbone for the data persistence in our database, which is just a technical thing really. But we're actually using ISO 95 as a minimum, when we engage with customers, to say, here's part 2, here's part 4, here's part 3. These are the checklists of things that we need to visit. These are the checklists of things that we need to look at and consider if we're going to take this group as a whole. And then just like in a surgical environment where there's somebody there with a checklist making sure that all the basics has been done, ISO 95 gives us that backdrop really of confidence in, we really are quite confident in how to engage with this domain and kind of lift some of the nuance that's happening within these data streams and within these data structures, and put them into a place that's sensible and common and can be well understood. And then from that beachhead that you've established in the early stages of a project, you can then move forward and go on to solve the computer science problems.
Excellent. So, again, as I introduced this topic, it was, the ISA 95 was, we just think about it exchanging data. But I think really what the power here is that in your example of where I'm going to have this property that I would call the standard rate of how does this material run on this particular piece of equipment, it gives a lot of flexibility in doing it. So it's not so much I'm just here to try to exchange data back and forth. The ontology means that I have this property existing in a certain location because that properly reflects how we go about doing our manufacturing process, so that I don't want it in any process segment or in an operations segment. I need it down at that work request level for it, because that's how we describe our manufacturing process. That's what makes sense in this context. So, with that power, that when people want to consume the information back, and that's fundamentally where we're trying to get is, I need to be able to query and interrogate data so I can start making better decisions. If we have an ontology for describing it versus just a mechanism for exchange, that's really where the power comes in on the idea of the ontology here. Absolutely. Perfect. So with that, Andy, one time you and I talked a little bit about, what if I were to take these ISA 95 models and apply that to the edge? So for instance, in a UNS type architecture, I may be bringing down a work order, and I say at runtime, meaning the operator is getting ready to select a work order, and I'm going to now process it. And there's a whole payload that's associated with that. There's a lot of data that's there that allows me to, at runtime, now run the plant, because there's all the, there's a BOM, there's some specifications that are associated with it. There's a lot of information that's there. What if I were to apply the ISA 95 model to all these events? So for instance, when my ERP, I have a new work order that's created, it's going to give me this operations schedule, and I'm going to present the data that way. Or I'm going to have an operations request, because now once I've scheduled it, there's now a request for all the operations and all the segments that are associated with that. And then of course, I'm also going to get the operations responses. So, that'd be that level 4 to level 3. Or if I'm just doing between, in the part 4 of the standard where it's getting information back, I'm going to have my work master, my work schedule, work request, work response. That's going to be something that's even more granular at that level. And why I brought this up is because if I'm looking at an enterprise where there are multiple sites, they may go about building their UNS differently, because I have found that typically these are these standalone events. There's not the data governance piece that needs to be there. So can we abstract that out to where you can build it however you want, but utilize these objects? So I'm curious just your thoughts on maybe that approach. So instead of me just building a semantic data model, which just says these are my lots, utilize the model and the relationships of the model in doing that.
Yeah. Okay. Yeah. It's an interesting approach to take, and if you're like earlier on, I sort of mentioned about how REST and MQTT or broker-based sort of publishing can be similar in that the part of the technical implementation for where you go to get the data, the topic structure or the path structure, if you like, the URL structure in REST, it defines what you're going to be able to get off that endpoint, or defines what's going to be available on that endpoint. So if you take the approach with a broker that says that says that what we're going to do for a particular piece of equipment, we're going to have enterprise site area line, and then underneath that we're going to have a complex, make a complex ISO 95 object available, like an operation schedule or like a job order and that kind of thing. Then that's perfectly possible and probably very convenient for the key events, the events that you're going to be interested in. For the concrete events, for the things that you can build functionalities off of, for the things where you've got a dashboard in Grafana and you know that this dashboard is going to visualize a very specific payload that is a combination of job responses. It might be a combination of, there might be some time series data and that kind of thing in there. I think if you know up front how it is you want to consume the data, then I think it's very easy and convenient for you to be able to compose that data structure and put that data structure onto one or several, a small number of topics, or a small number of endpoints in REST, for example, that allow you to conveniently respond to changes in that data and reassemble the relationships between those different pieces of data. And it might be that you could choose the approach, I wouldn't, but you could choose the approach that says, for this Grafana dashboard that I'm building, the back-end data payload is going to be, this complex JSON object, and I'm going to fetch that off my broker. I'm going to fetch that from a specific REST endpoint, and I'm just going to keep calling that REST endpoint. I'm just going to keep subscribing to that broker topic, and that's going to give me everything I want for my Grafana dashboard. That could be a convenient way of doing it. The difficulty comes and that's great, but then it's when someone asks you another question in a project, is when somebody asks you to do something a little bit more complicated. So what you need to do is you bring in another variable from another part of the graph that's suddenly become interesting, and that's where the burden then is that you're going to have to sort of rebuild that payload structure somehow. So whatever it is that's actually populating that REST endpoint, whatever it is, it's resolving that data, needs to change. So I think if you're going to build S95 endpoints for these sort of more complex objects and put them into your broker, then the trade-off is going to be around the flexibility of how you go about building complex relationships to inject into your payload. And I think there's probably a balance to be struck between assuming that everything just gets baked into one payload and goes onto one topic, versus having a distribution of the kinds of data that you might be interested in, like availability, performance, that kind of thing, as against current run, current quantity left. You might have some core sort of foundational objects on there that are convenient to reassemble and to manage the relationships between those at runtime, at query time, at display time, or whatever that might be. But I think you need, as an architect, you need to be aware of the burden that you may be putting on the client and the consumer, that they're probably going to need to rebuild the relationships at some point. That's the thing. Whoever's putting the data, whichever actor is putting the data onto those topic structures, has got to also be aware of those relationships. And the other thing that you've got as well, you've got a kind of a concrete topic structure or URL structure in place there, which everybody that's consuming needs to understand that somehow. And so every consumer is going to end up somewhere in their configuration with some kind of model in the configuration that reflects that which is in that broker, or that which is on that REST, that sort of REST URL structure. So we've got a duplication there. So if we do go and change our equipment hierarchy, for example, that may, unless you're really clever about the way you design everything, that may have quite the knock-on effect. So yeah, I think if you're introducing these more complex events into a UNS environment, then I think it's just it's about understanding the trade-offs of that, and I think it's about understanding what you're trying to get done for the customer. Because the thing is with architects love to architect things and go the whole hog and get everything perfect. And in actual fact, what you really might want to do to get value into the customer is just get my job responses onto a topic structure for that equipment so that I can consume it in Grafana, and that's great. But then, it's your next problem, and it's the problems that come 2 years down the line that you need to sort of be aware for, and not necessarily over-architect for, but just be aware that they may be coming. So yeah.
Perfect. Yeah, I mean, a lot of this came from the idea of how do I abstract the models that I'm doing here. So if I have a company that makes, I make widgets at one plant, but I'm making juice at another plant, I might go about architecting this data a little bit differently. But if I were to utilize the models that exist within ISA 95, I can abstract that out. So now my resources, my asset, my equipment, my personnel, and my materials, that falls in there. The next logical piece in this mental exercise was that it also makes it easier for a manufacturing data hub to consume that information because it's already somewhat predetermined. But say I take that UNS and I'm going to put it into some kind of either a time series database or some sort of data warehouse where it's just a large table and bring all that data together. I'm going to have this really great time series representation of all of these models and all that information. But it became pretty clear, and you've mentioned it a couple of times, Andy, of unless you understand the relationships of all that data, that's where you're really going to struggle to create value out of the data that you've already collected. So let's explore that a little bit. So Geoff or Andy?
Go on, Geoff, I'll let you go.
Yeah, look, and we've probably covered a couple of examples that are really good to call on. But if you've got, your a table of product information in there, and you're running a particular product on your machine, but you might publish out in your unified namespace topic a JSON which says, I'm running this product on this machine, which is okay, but it's then how do I get to the other information if I might want that? So if I want to know, who was operating that machine at the time, kind of going back into what Andy was talking about before, which is, okay, I need to subscribe to this topic, which say what product was running on the machine. I need to look at the time, and maybe the timestamp is on that message somewhere. And then I need to use that information to go back and either subscribe to or query from perhaps a different topic that has who was operating the machine at that time, so that I can kind of join all this stuff together. Because it's the joining it all together which is the valuable bit. Each of these bits of information on their own is interesting, but not hugely valuable. It's when you join it all together that you get the value out. And so, why do we have a graph database, or why do we have a GraphQL endpoint in Rhize? It's so that I can very easily ask whatever question I want to ask of the data hub. So if I want to know, who was operating the machine when it made this product, ask for that. And I don't have to care about, that is actually spread across 4 different topics and it's in several different payloads and they need to be pulled in and then joined together and find the answer out of that. The data hub is doing that for you. You just ask it for what you want to know, and it's built to be incredibly fast and efficient at doing all of that work of giving you back the answer to the very specific question that you asked from it, because it's got all of that relationship built into it. And as a consumer of the information, it's still pub sub. You can still subscribe, but you don't have to subscribe to a topic. You can subscribe to a query across topics. So if I want to subscribe to a set of information that says, which operator was operating a machine and what was running on it at the time. If I'm as a subscriber want that payload, I can ask the broker for that payload and subscribe to that. There's nothing on the publisher side that has to pre-build that payload and send it to me. The publisher doesn't need to know what I'm interested in. And this is the power of the data hub. Publishers can publish their information. The data hub joins it all together in the ISA 95 standard model. But a subscriber can ask for what they're interested in across all of the various bits of information on topics that went into there, and get exactly what they want back out of it. And that's the really powerful part.
Excellent. So Andy, anything that you'd like to add to that?
Yeah, well, I always use the phrase recurse and traverse. That's what we that's where the value comes from where we're querying our graph databases, that we can recursively visit objects that work our way up and down hierarchies pretty conveniently. And then when we get to the point that we want in the hierarchy, we can then traverse across to get context. And you can keep going in a graph database. It's quite intuitive to be able to start a material lot that you're interested in, and then sort of, in old-fashioned sort of object notation to say, to look at a material lot, to say material lot dot material actual dot equipment, and then you can look at where that material actual or where that material lot was produced on. So you've got this, this ability to go up the chain and visit the equipment from the material, but equally you can look at a piece of equipment and then say what job orders ran on this equipment between these days. Grab your job order and then go into the job responses and then go into the material actuals and then find all the equipment, all of the material lots that were produced and consumed, on that particular job order. And the two approaches to material lots, yield a similar understanding, but the journey through the graph is different, and the journey through the graph depends on where your starting point is from, what it is you're thinking about at a moment in time. So starting in a convenient place and leading to somewhere else has got a degree of convenience and exploration that's quite intuitive, and as I've said, being able to do that in a relational database is a degree harder and much more technical. So it kind of inhibits your ability to think in the way that you might want to think when you're exploring these sort of complex object models.
Yeah, absolutely. Yeah. It's that's a perfect example of when I think about how would I do a genealogy or track and trace, that if I need to get into lots and sublots, I can certainly model those. They're part of the material model that's there. But again, I think it's the importance here that the takeaway is that if you don't understand the relationship of all of this data, even dumping it into something is really not going to benefit you, because now at what I like to call runtime, or at query, the operator needs to or the person who wants to understand this data, I might have to rebuild that with those relationships in my query, and that's some of the problem.
Yeah. That's a great example to explore the traceability, the genealogy and traceability use case. One lots of people in manufacturing deal with all the time. If I have a piece of material, what was it made out of? So what are all the components that went into making it? So can I look at this, this sublot in ISA 95 language and look at all of the components that we used to make that? So what is that made out of? But then maybe I put that thing, let's say it's a mobile phone, I might put 20 of them together in a carton that has a label on it. And so then I've got this, is part of another lot. And then maybe it got shipped out and went, so what is in it and where did it go? What did it become later on, this upstream and downstream traceability question. And then you've also got the, and what happened in the process. So which machine was it made on? What was the process variables of the machine that made that? When was it made? Who was the operator that was operating the machine when it was made? And what the relationships in the data, when combined with the GraphQL language, gives you is the ability to ask for all of that information in one request, where no developer has to think about building you a particular answer to that question. You, as the consumer of the API, can do all of that yourself without needing to go and get anybody to develop anything for you if you've already got that data in the database. So, and if you change your mind and you say, well, actually, I don't need to know the operator, but I really do want to know the average temperature of the machine that particular my mobile phone was made on in the factory, then I just change that in the query, and that's the response that I get back. But I get it in one request. So I get all of that information. I don't have to, pull all the separate bits of information and then join it together myself in code and then figure it out. I can ask for all of that and in one request in 20, 30 milliseconds, get that answer back and in the format that I asked for it in.
Yep, absolutely. No, it's perfect. So, which, interestingly enough, you've segued us beautifully into the last thing that I wanted to talk to you about when you say the average temperature. We've been spending a lot of time talking about events within manufacturing, but there's also this time series data that's been referenced a couple of times here. So within the context of a manufacturing data hub and in Rhize specifically, how do we go about working with the time series data? So for instance, you want to know the average temperature. There's going to be this temperature sensor that's out there, and I'm going to look at this event, and there's going to be this job response that had a start and end time, and now I can bring that back. But how do we integrate with that? And what does time series data look like within a data hub?
That's a great one for you, Andy, because I know you've been working with exactly that question recently.
Yeah. Okay. Okay, so yeah, time series. How does that work with the data? The data. We've got particular types of data that lend themselves very well to time series, and they're reasonably obvious to most people. So tag data being streamed out from the operation and through into time series is kind of a fairly obvious use case, and time series databases allow you to use time and date as a first class function. So we've got convenience features in there that are highly performant, and we can do things like query the database, and we can do grouping and windowing on time. So effectively, you can group by minute and bring all your data out of the database. And if you're querying, a number of different measurements or a number of different tables in a time series database, then you can structure your queries so that for a given 24-hour period, no matter how many events you've got in your database, you can bring out, if you're aggregating by minute, you can bring out exactly 1,440 records in that data set, and then join them up with measurements from other tables in time series and match those up, and you can synthesize the data that appears in that data set so that you're bringing out, if in a given minute you've got 1,000 values for a temperature sensor, then you don't want to yield 1,000 records. You'd yield one record with the average for that minute or the highest for that minute, some kind of aggregate and that kind of thing. But in a given minute, you might have no records in your database because the temperature only changed once for the whole day. But you still want 1,440 records in your data set for the convenience of feeding it into Tableau and doing the turbo pivot that Tableau's so good at. So what you want to do with it, with the time series database allows you to synthesize the data and bring forward it's called last observation carried forward. So you can bring the value that you had 4 hours ago and use that to populate or sort of copy down, if you like, if you to use Excel terminology, the data from time series. So and treat that as your values. You've got ways of grouping by, aggregating, interpolating these data structures that you've got stored in time series, which can be very it's a powerful way of being able to lift that data out of your database. So and that's a first class function of a data hub. So you might want to go direct into your time series using native protocols. We've got a few ways of supporting. We use the CQRS pattern, for example, when we're working with time series. So we've got a dedicated sort of query engine sat on top of our time series that allows you to sort of go in and pull the data the way that you like. But what we've also got as an implementation piece within Rhize is we federate the time series data into the supergraph, into the GraphQL API that we've got. So a specific on specific objects that are going to have time series database sort of behind them, or you're interested in time series database, for example, equipment. What you might want to do is construct a GraphQL query that says, show me all the equipment, and GraphQL automatically gives you a kind of a group by behavior. If you start off with your query by asking for all the different equipment that begins with the letter B or something like that, then you might get 5 records at the top level. And you might ask for, the ID of the equipment, the name of the equipment, that kind of thing. And you'll get a handy JSON structure there that might have sort of an array, 3 items at the top level for your 3 pieces of equipment. But then you might want to drill into this equipment, and you might want to say, okay, so give me the value of property X. And if you just ask for the value, then what will happen in Rhize, it will give you the current value, the value that's, the last transmitted value, if you like, that's come through the broker. And that's convenient. So you'll get these three data structures at the top level in your in an array, these 3 pieces of equipment with the current value. But then what we can do with this federation of time series is to say that what we also want to do is ask for the history of that property value. So let's get the history of property value temperature. That's the property of choice that we've been talking about today. So you might submit a query that says, equipment, description, value, and then history. And then, the history object on our database allows you to supply a couple of parameters, a start date, an end date, whether you want to do some aggregation work on that historized property, that kind of thing. And what you'll get is, let's say you just want to look at the history for the last hour for those pieces of equipment. You'll get, a JSON structure back from the database that is, your 3 pieces of equipment, and then embedded inside the JSON structure in the correct place. And it's important to emphasize that we've got this natural group by thing going on that says that when I explore my data and I've got the payload back, underneath the equipment as a child of the equipment, I've got my history values there in a kind of and that would also be a JSON array. We might have for the last hour, we might have 1,000 values coming in. So for the equipment, 1,000 values are going to be sat under that piece of equipment, and for the next piece of equipment, you might have a different number of values. So the data gets embedded right there within the GraphQL query, and we can extend that kind of concept out to something a little bit different. So maybe it's not that interesting to look at the history of a piece of equipment, really. If you really want to dig in and make improvements, it may be that you want to look at the telemetry values for a particular equipment for a particular job order, or you might want to compare two different materials that get consumed on the same machine and see if the process values differ. And then in that case, if you're querying job responses, what you might ask for from the database, you might ask for this equipment, give me the job responses for the last 20 days for this material as a filter. And then you might say, within each job response that we're getting back from the database, give me the equipment actual object. And under the equipment actual object, there will be some history data there. And what we actually end up doing is at the point at which we want to draw history for a particular job response, for a particular piece of equipment, our federation technique, if you like, allows us to go off to the time series database and use the start and end date of the job response and a filter for the equipment ID that brings back the history for that specific job response for that specific equipment. And again, we've got the convenient, natural, intrinsic group by that's happening within the GraphQL that seats this historized data underneath our object. So, that's great to feed, Grafana and that kind of thing, or other reporting tools, or maybe for data exploration and whatever that might be. So we've kind of got through that method and through all the methods, because it's not the only way, the way to skin that cat. When we place these resolvers, these time series resolvers at strategically sort of important places within our data model, it allows us to automate the contextualization of the time series database that's stored there. And naturally include it in response payloads from the database that give us this grouping and this contextualization. We can invert that as well. So that's one way of doing it. With time series, people want to look at data and go direct to the time series database in a lot of cases. In which case, when we push data into time series, the part of the technique that we use is we not only include the raw values that we're receiving from the plant floor, we also do our best to resolve context before we persist to time series. And what we include in the time series is not just the raw data, and we also include primary keys into our graph that we think are going to be convenient later for people to join the context data that lives in the graph up with the data set that they're pulling back from time series. So it may be that you're for job response data, for example, if we're streaming data into time series from live production, we would probably include the equipment ID, the equipment version ID, the equipment class ID, job response ID, material ID, whatever context that we know is happening at that moment in time. We would generally, if we can, push that data into time series. And then when we're building dashboards, or when we're trying to work with that time series data, what we can do is, we might want to pull a data set back from time series, which is, it might only be 20 rows long, but it's an aggregation of 10 million rows that lives in time series. So we'll pull back, we'll use the time series sort of performance and the goodness of the time series queries that we've got access to traverse this, million rows of data, pull in all our aggregation, do our filtering. And then what we end up with is a data structure back that's got the aggregations that we're interested in across not only 20 rows and a bunch of IDs that allow us then to go and visit the graph database to pull other interesting context out. So if we've got the material ID, then what we can do is hit the graph database and pull the material description out and maybe some other stuff that's associated with the material. So maybe the material class, and if we've got the material class, there may be a property on material class that defines the material supplier or something like that. That's probably a bad example. But again, if we can bring our use time series and the power of time series to bring back this smaller aggregated data set we can then go off and visit the graph and collect all this context that we're interested in, and pull that back into that data structure and manipulate it and put it on screen and do that kind of thing with it. So we've got this kind of inversion of context exploration that we're able to do. So that's quite I suppose what we're really saying is we've got this composition of two very different databases, and we sort of work hard with GraphQL Federation to find a route into time series through the graph, and we work hard with sort of primary key pre-contextualization within time series to give us a convenient route out of a time series response and back into the graph to collect our context, and we can kind of avoid the need to, in that second instance, to be duplicating lots of context data that we're not necessarily, we're taking up a lot of storage. We've got the convenience of graph storage efficiency rather than duplicating data in our sort of Parquet files in our time series database or Postgres or whatever it might be that we've got as a persistence layer at the storage end. So that's the whistle stop tour, I think.
Sure. Yeah. It sounds like there's a lot of ways that the data hub interacts with time series data. It could be raw. It could be the contextualized. We're pushing that data in, or we're just bringing back based on a query. There might be something that is predetermined that we know we're going to want this type of information. So we'll construct that ahead of time to take advantage of the efficiencies within it. So,
correct.
Yeah. A lot of great stuff. Geoff, is there anything you wanted to add with relation to how we do time series data?
Yeah, just one, and that is, this is it's not a new problem. I'll pick on a phrase that was used, I think, in the last podcast or one of the previous ones, which was, everything old is new again. How we put time series data in context of the manufacturing process is something that companies have been trying to solve for a long time. The key to it for us is ISA 95. There's all the computer science magic that has to happen, and there's a lot behind getting it to happen there. But the key is ISA 95 is a bit like this, fishing net. Rhize as a word is an abstraction, or comes from the term rhizome, which is like an interconnected network of things. So you can think about that like a fishing net, and imagine you've got the fishing net sort of laid out on your kitchen table, and you can go and grab any of the knots and pick that up, and it kind of brings the net with you when you pick a part of that net up, and that's like a GraphQL query kind of bringing data connected through relationships with it when you pick that up. ISA 95 gives us this pre-laid out fishing net of all the relationships and all the bits of data. But it also tells us which ones of those should have what type of time series data attached to them. And I don't mean like which sensors. I mean, where does equipment property, where does it make sense for an equipment property value to be attached into that fishing net of a big network of information? So because it lays out that for us and gives us the structure there, we can kind of pre-build in the relationships that make sense. And then, you can go and grab a part of that net and pull on it, and the time series data will come with it in the right place and end up in the right place in the JSON file that can come through. So it's this combination of how we do contextualization, how we do ingestion, and how we kind of manage the relationships, and then the API, and then the ISA 95 on top. It's like this magic that happens when you get all the right components put together.
Excellent. So we've certainly covered a lot here on the podcast. Believe it or not, we've been going almost 2 hours now, so we're probably going to break this into a couple of different episodes. But I'd like to get into some final thoughts. And for me, we've started off, even in the podcast series, we're going to talk about a unified namespace and let's get it defined and how we apply it. And it almost seems like the Uber broker and then ultimately the MDH is that logical progression of how we're going to we're going to digitally transform our manufacturing processes. We're going to start with this. Let's get data, get those data models built. Then we want to now start building in some functionality so we can run functions and methods and in queries, and even add in some metadata. So that's that next logical progression. And finally, we're going to have this manufacturing data hub that, for all intents and purposes, it gives us this ontology to describe our manufacturing data. So, to me, it's almost like all of it's important. It's all necessary. It's just that logical progression. It's sort of where I landed on this. But the key is just understanding that the relationship of the data. We can't just have one. We need to evolve and advance what it is that we're doing. So, Andy, any final thoughts as we close out here?
I think the only thing I'd like to add, just to a general overview of Rhize and our use of ISO 95, is that when you talk to the ISO 95 consultants, they love ISO 95 because it allows them to express themselves. So they can do some analysis and they can find, they've got OCD, these guys. It's ridiculous. They really want to find somewhere to put the data, And ISO 95 allows them to actually finish the job of doing that and get to the end of, this is analysed. It allows them to express themselves. That's why on the consultancy side, we like that so much, and there's no limitations because our API provides for all of that. It provides for the whole ontology, so that's really convenient for them. What we've also got on the technical side, from an architectural side within our stack, is a bunch of architectural building blocks, the NATS broker, graph, time series, federation, microservices, rule engine, core, edge agent, and BPMN. I've forgotten BPMN there. And there's some stream processing in there. As an architect with a specific problem to solve on a specific use case for a customer, that bunch of architectural building blocks, and that allows you to express yourself as an architect to a fuller extent than I've been able to see with other systems. And it allows you to actually, from a project delivery point of view, it allows you to understand the use case really well, because the consultants can do their job on the ISO 95 side. You can put down a really finite architectural piece, and because of the way that the tools are constructed, you can plan out a project delivery program where you know what needs to happen. There are no mysteries. The computer science problems have been solved. So we've got this kind of convenience of expression for the consultancy and the manufacturing analysis side, and a convenience of expression from a technical architecture side, which has got a kind of a breadth and depth that you don't really see if you're just going to consider, an MES or, AUNS or a partial piece. We've got a lot more sort of tools in our box, and we can wield them with care to bring about, quite efficient solutions for specific use cases.
Yeah, great point. Geoff, any final thoughts, comments you'd like to make?
Yeah, look, probably two. So what makes a manufacturing data hub a manufacturing data hub and not just a data hub? It is an interesting question. The answer to that is ISA 95. If it wasn't for ISA 95, it would just be a data hub, not a manufacturing data hub.
Yeah.
And so there's that, and that's data governance and its consistency, and it's this incredibly rich, incredibly precise language that it provides. And the other thing is, we've talked about this kind of toolbox of components with rule engines and stream processing and workflow and APIs and all this good stuff. And it's possible to go and collect individual standalone components that do all of those different things. And it's even possible to assemble them into a solution. Given enough time and enough smart people, you can do that. But it's really, really hard to do. And it's even harder to make the end result usable and sustainable and going. So, what we've had to do is actually not use a lot of the components that you can kind of go and get to assemble a solution, but kind of purpose build a lot of these things so that they work closely coupled together and they work as a harmonized solution set platform that our customers can go and get and use. Individual components, if you had to kind of pull them all together, it's an unwieldy beast if they're all individual components of a solution. So, this is exciting. The problems that we can solve, we talked about genealogy and traceability and things, the problems that we get into, that we talk to customers, companies about, that we're solving now with the technology and the language that we've got to describe these things. Problems aren't new, but some of these problems have sat there unsolved for a long time because the approach and the technology hasn't been ready in the past to try and solve these things. What we're finding now is that we can get in and solve problems that were unsolvable previously because of the combination of the tools and the language and the approach, which that unlocks value for companies. That's how companies can really take that step forward. So it's exciting.
Yeah, agreed. I mean, it's been very deliberate about what's here. That was as I first started exploring the manufacturing data hub, or what we now call Rhize. Very deliberate on what the technology that we're using, and a comment that I've made is until we've had this robust technology that is part of our platform, that's what made a lot of these things difficult. That now it's not easier. We're not solving anything new. We just now have the ability, the programs, the applications that we can now stitch together and solve it. So with that, Geoff, Andy, thank you so much for spending some time here today, and to our audience, thank you. I know we covered a lot of information. And look forward to seeing you on the next episode of the Rise Up podcast. Everybody, enjoy the rest of your day. Thank you.
Good stuff. Thank you. Cheers, guys.